All right, everybody. Next up, we're going to talk about our flight controller and our connections to the ESC. You want to get familiar with this web page here. This is the manufacturer of our flight controller, Maytech, or Maytech Sys. I'm not sure how you pronounce that, but usually they're called Maytech flight controllers. This is the H743 Slim V3. Here's a bunch of specs and cool stuff about it. If you're interested in some of this, that will give you a lot of information you need to know. As we scroll down here, we have all these different tabs. Okay. So all of these will be useful for different things. We are going to be using ArduPilot in class, so this ArduPilot mapping tab will come in handy. Okay. But if we go back to the specifications here, we can see all of the specs of the board. Okay, so if you're interested in certain things, you might be able to find them here. If you're interested in adding FPV or something like that to the copter, that has some information about that and that kind of thing. We see that our flight controller is rated from 2 to 8S. Okay, so even higher than our ESC is actually rated, which is nice because that means we can use basically any battery we want. There's no bottleneck. Between 3 and 6S, we're good to go. ESC can handle it, flight controller can handle it, and our motors can also handle that. So that's great. What I'm going to focus on right now is some of the layout and wiring. So this layout tab here is really nice. Explains all the different pads and ports and all that cool stuff here. Okay. And then here's a diagram for the wiring. Okay. Now be aware, in the wiring diagram, it may not be exactly what you need for every circumstance. Okay. For what we're using in class, it works pretty well. But for other things, if you're adding things outside class, be aware that sometimes the pins and pads are used differently in ArduPilot compared to how they're used in other flight controller software like Betaflight. And so you may want to double check things before you solder things up. Just because they can change. Hopefully that makes sense. Just let me know if you have any questions. Okay. Well, the layout here is really helpful. We can look at the top of our flight controller here, or I guess you can call it the top. And then we have the other side here. Okay. What we're going to focus on right now, particularly, is the ESC to flight controller connection. Okay, so see on the bottom of our flight controller here, we have our USB-C port over here. We have our SD card slot right here. We have our boot button right here. And we have a CAN connector here and basically a 8-pin connector here, which we use for our ESC. Those are our main items on the bottom of the board. Most of the other soldering is going to be done on the top of the board with all these pads. Okay. So we're not going to be using the CAN port in this class, so don't worry about that one here. That's the 4-pin connector. We are going to use the USB-C. We are going to use our SD card. We are going to use our boot button. And we are going to use this 8-pin connector here. Okay, so let's flick back over to the dock cam for a second, and we'll look at that. All right, let me turn this off. Oops. Okay, there we go. So we just looked at it on the website there, but we have our USB-C, our SD card, our boot button's kind of hidden, but it's right here above the SD card. It's hard to see, but there's a little button right here. Okay. We have our CAN connector here with 4 pins, and we have our other connector here with 8 pins. Okay, so the CAN connector we're not using right now, but we are going to use this one. Okay. So what happens here is the ESC has an 8-pin connector and the flight controller has an 8-pin connector. And so we need to plug those together, but we can't just plug them in blindly. We need to make sure the wires are in the right spots. Okay. So for the SkyStars, you can look on the ESC itself, and there's a couple different spots available. I'll try to get them in camera. You may just have to look at your own and reference what I'm doing here. It's going to be hard to see these numbers. Okay. Okay, there we go. So it's upside down right now, but let me try to point at some of these things. You can see these little words and letters and numbers. There's 1, 2, 3, 4, and there's 1, 2, 3, 4. Okay, those are labeled there. They're also kind of labeled here on the top of this little shell. Okay, and it's a little bit harder to see here, but there's a C, N, 4, 3, 2, 1, B, and G. Okay, so labeled on both sides kind of in different manners, right? But what we have going on here is basically we have a ground, a battery voltage, and we have signal wires for motor 1, 2, 3, and 4. We have a wire here with the N that's not really used. We don't use that one either. And then we have a C for current. Okay, we'll flip that over and probably go over that again. Let's see, turn it around this way so you guys can read it. Okay, you can kind of see here we have a GND for ground, BAT for bat, S1, so motor 1 signal, S2, 3, and 4, NC is not used, and then CURN is current, okay? And that's our ESC pinout. Since it's just on the ESC, might as well just reference it itself. You can find, I believe, a document for the ESC as well online if you wanted to reference it that way. But it's printed on here, so it's not too hard. Okay. However, on the flight controller side, we don't really have a good reference per se. There's nothing written here on the board, so we need to look at the online documentation. Okay. So what we're going to end up doing is making sure that when we plug the ESC into the flight controller, we have everything wired correctly. Okay, this is a real big gotcha. If you wire this wrong and you power things up, you can fry your flight controller and or your ESC. With together, that's over $100 if you fried both of them. Okay, the flight controller alone is about $100. So please double check with me. Be careful. Don't power it up until you're sure. Okay, this is an easy spot to make one little mistake, and you need a new component. Okay, so if we go and we compare this pinout here to our pinout on the Maytech website, we can see that, we have our pinout right here. Okay, 4321 RX8, which is the one we're not using on the flight controller side, current, ground, and VBAT. Okay, so again, the equivalents are here. The VBAT is battery voltage, G is for ground, current is current, RX8 is not used. That's the same as the NC port on the ESC. And then we have 1, 2, 3, 4 for our 4 motors. Okay, so that's how that's pinned out. And so when we go to our ESC flight controller itself, okay, we're going to have to adjust things a little bit. Excuse me. I'll show you guys on this spare connector. So you get a couple of these type connectors with your ESC, and then you get one with your flight controller. I ended up using one with the flight controller because it was long enough. The other ones are a little bit short for the way we need to orient things, in my opinion. But we can show you the process with these just the same as the other one. So I'm going to pull this over here. Okay. So you'll see the connectors, kind of like the Futaba connectors we used in class, have a bunch of little pins in them. Okay. Get the camera to focus on this real quick. Let's try, come on, camera. Okay, there we go. So each of these little pins, which I'm actually pointing with the spare wire right now, one of the pins, is slid into a groove, and there's a little this little white finger that catches the pin. And they're much smaller than the Futabas, but the same principle kind of applies here. There's a little tiny barb or hook on the one side of the pin, and the other side is the part that makes the contact. I know that's really hard for you guys to see in the video, but once you get your hands on it, it'll probably make more sense. Okay, so when we're adjusting connectors like this, if we want to remove a wire from the connector, we have to pry up on that little teeny white finger tab and then gently pull the wire out. And don't pry up too hard or you'll break it off, and this piece of plastic will then be useless for that purpose. Okay, just pry up on it a little bit with an X-Acto knife or a very small flat-bladed screwdriver, and you can slide the wire out if you want to remove it or change its position in the lead. Okay, if you're going to insert it, you need the little hook piece that's opposite of this larger tab to be facing towards the white fingers. So as you slide it in, the hook will catch on the little white finger tabs. Okay. The other side that kind of protrudes more is where it makes contact when you plug this whole connector in to something. Okay, in this case, into our flight controller or ESC. All right. Okay, so what you're going to have to do, and again, I'd recommend using this harness because it's long enough. These ones are a little bit short. The ones I give you with the ESC are a little bit short. And I'll show you why in a second. Okay, you need to make sure that the harness, as you're using it, has the wires in the right spot so they match up. Okay, mine's twisted for, aesthetic's sake and a little bit of tidiness. Yours won't be twisted when you get it, so it'll be easier to make sure that, ground goes to ground and power goes to power, and signals 1, 2, 3, 4 go to 1, 2, 3, 4, and current goes to current. Okay. You notice they're not symmetrical, so like the wires aren't in exactly the same spots on each side. So you need to pay close attention to this so you make sure everything's working. Okay, it's not a direct crossover. We don't have power on top and power on top. See, ground's on top here and power's on top here. Okay, so you have to get your hands on this and play with it. Move things around, look at how they work, because it's hard to show you all possible combinations here in the video. But the idea is you need to make sure this is correct going across here. Okay, please be very careful with these connectors. They're not super durable, and I don't have extras of them per se in this same type. Okay, so I want to double check if you want to practice moving pins around and removing pins and stuff with some of these ones that we're not going to use. That's a great idea. Okay, and then if you break a tab off on this, not a huge deal because we're not going to use that in the end. Okay, let's show you for a second why I'm using the larger harness, okay, or the longer wire harness, we can say. We go back to our plate here. All right, we're probably going to want our ESC to be either facing this way and going out this hole, like we talked about in the other video, or perhaps facing this way and have the wires come up here and go out the hole. Okay. To me, that makes the most sense. You may order it differently. I mean, you can do it however you want. If you want to put it sideways, that's fine too. Okay. But the flight controller, if we want to not have to mess with it in the software, which is not that hard to change its direction in the software, but if we can put it the right direction, we might as well. Okay, there's this arrow here, and it should face forward, whatever the front of the copter is. Okay. So I believe the way I had this set up earlier, let's see if I can remember now, I've taken it off a couple times, was something like around, something like this. Okay. And actually, no, I had it upside down, sorry. So we had the arrow facing forward, but it was upside down. So we are going to have to change in the software a little bit anyways, I guess, so maybe not that big of a deal. But I believe I had it like this. Okay? And so you see this harness needs to go from ESC to the flight controller, so this one's long enough. These ones aren't quite going to be long enough. It's going to be a stretch to try to get that to reach around a side. Okay? And I also did that because I wanted the USB port for the flight controller out the side, not out the front or back. It doesn't, you can do personal preference. It doesn't really matter. We can change all the orientations in software as far as the flight controller goes. Okay? If you do use a different motor order than other people, you will have different motors be motor 1 or 2 or 3 or 4 will be different for you than other people. Now that's not impossible to figure out. It's just going to be different, if that makes sense. Okay. So as of right now, I believe I'm going to have my ESC facing this direction, and so my motors will be in a specific order. If you rotate your ESC, which is totally fine, and you solder up the motors like so, okay, your motor over here is now attached to these pads, whereas before it would have been attached to these pads, right? So that'll make it a different motor in the software. There's nothing wrong with that. It's not going to hurt anything. It'll just be different. And what you don't want to do is run your wires from the motor over here, run them all the way around to this pad. That's just, there's no point in that. Okay? But if you do want to orient your ESC this way, perhaps, and run the wires like this out to the hole, that's fine. That's not a big deal. Okay? And in that case, perhaps you could use one of the smaller wire harnesses, because they would reach in this orientation. Let's see here. If we orient it like this, for example, there's plenty of space for it to reach here with a shorter wire harness and go like that. Okay. Like I said, and the USB is still out the side of the other side. So there's different combinations you can do, if that makes sense. I think I'm just kind of stuck in my tradition. I want it to be facing forward, even though it doesn't really matter. Okay, but do with that as you may. Make sure you figure out which way you want to do it before you choose your harness, because you may need the longer harness if you're going to the side, like so. Okay, but if you're going to orient things in the same position, you don't care if the USB port comes out the back, then you can use a shorter harness. Okay. One reason I don't like the USB harness coming out the back, at least lined up with the ESC, is it's going to be right by the battery leads, and that's going to be a little bit harder to plug the USB cable in. Okay. But of course, if I want the USB coming out the back and I put my ESC sideways, then we're good. You know, that's not an issue. I can have it plugged in the back. Motor leads or power leads are over here, so no big deal. Okay. So do that as you may, but that's the reason for that. Okay. And on the flight controller, we have the gummies as well. Focus on this. We talked about the ESC gummies in the ESC video, but these ones are also asymmetrical, so they're longer on one side than the other side. And if you're going to mount the flight controller like I do, and you want to have the longer side on the bottom and the shorter side on the top, that way when we place it down on top of the ESC, you get plenty of clearance. There's nothing touching between the two boards, okay? And that will work well, okay? As our final touch, when we're installing all this stuff, after we have everything soldered and all positioned, we will use some either normal hex nuts with some Loctite, or some nylock nuts, and we'll thread them right onto the top to make sure nothing's moving around. We're not going to crush things. We're going to make sure it's nice and sturdy, and that way the flight controller has a good mount in order to measure things and help the aircraft fly. So, okay. Hopefully that helped explain all the bits and pieces of the build itself. There'll be plenty of other instruction in class and in the instructions themselves here. I also have some written instructions as far as setting up software and things like that. Okay, but I was hoping with this to help you guys through some of the physical setup that's a little bit different and not covered in any of the other instructions. So, all right.